it says the distance along a path from school to home is 2 kilometers. Okay, so there is your school, there is your home, and if you walk on the path, it is 2 kilometers. But the displacement, now what is displacement again? It's a direct line between your start, your initial, and your final. Kamu, what are you busy with? Make notes. Okay, so your displacement is the direct line from your start, initial, to your final, your end point. Alright, so you can see there, from the school to your home, the direct line there, doesn't matter if it's on a path or not on a path, anything like that, 0.8 kilometers, northeast, because there is north, there is east, so it's in between north and east. Let's just check again, where's, in real life, where is north? Okay, alright. Then you can see here we have a skier. He starts here at A at time 0. Then he goes all the way to B at time 1 minute. Then he goes back to C after 2 minutes. And then D after 3 minutes. Okay, now they ask, what is the total distance covered by the skier in 3 minutes? Yeah. Rory-san, let's start with you. What did you say? Okay, so he didn't just go from here to here. Okay, he went from there to there, so that is 40 plus 100 plus a 40. What's that? That's 180, right? Then he went back there. So then he covered another 40 and 100, so that is plus 140. Then he went from there to there, which is another 100. Oopsie. Ay, toch. Another 100. So the total distance that he covered was 420 meters. Okay. So he went from there to there to there to there. Okay. Then they ask, what is the displacement of the skier? Okay, so the displacement is from your start to your finish. Started there, you finished there. That distance is 140 meters. Okay, but displacement is also a vector. A vector has size and direction. Okay, so the direction, he started there, he ended here, so he went. You can say to the right, or you can say east, or you can say in the positive direction. So you must give a direction as well. Okay, then page 4, question 4. They ask, which one of the following combinations includes 2 scalar quantities and 1 vector quantity? Okay, so yeah, tell me, displacement, is it a vector or a scalar? You can go to page 1 if you don't know. It is a vector. And acceleration? It's also a vector. And speed? Is a scalar. Okay. So they ask for 2 scalar quantities. We don't have 2 scalar quantities. Okay, so it's definitely not A. Let's check B, Carabello. Speed, vector or scalar? Scalar. A velocity? Vector. Distance? Scalar. Let's check. 2 scalar quantities, 1 vector quantity, sharp. So the answer is B. Okay, this is a good exam question. They love to ask a question like this in a test or an exam. So you need to know what is vectors, what is scalars. Okay, then back to page 2, please. We spoke on page 1 about what is a vector, what is a scalar, how do you show it, how do you represent it, draw it. Then on page 2, we spoke about position quickly. What is position? Position is your place that an object occupies. So what is your position regarding unicorns? Ma'am, I believe in it. Ma'am, I do not believe in it. You. Just leave it there, please, because it's been 5 minutes now since I wanted to teach. Okay, so I gave the example. What is your position regarding unicorns? Then, ma'am, I believe in it. Ma'am, I do not believe in it. What is your stance? Where do you stand on this? So position is a place occupied by an object. What is the position of your butt at this moment? It's on a chair in science class. Okay, what is your position of your bed? It's in your house. What is your position of what is the position of the national flag? It's hanging, it's hanging at the moment here in front of the school. Okay, so position is just the place, right? Then we spoke about frame of reference. Frame of reference has an origin. What is another word for origin, Retabile? Origin. Guys, you know what happens when you don't know? And you got okay. So it says there, frame of reference has an origin and it has a set of directions. Glonnie, you must look at the back of the book, is the English words. The back of your book. The back of the book? What? The second half of the book is English.
The first half
is Afrikaans. So you want to look up the English word to give the Afrikaans. So you look at the second half of the book. Yes, Ritabile? Hey, shh, no.
Should I say all of it or?
Yes, all of it.
It is a base or basis or foundation or fountainhead, inception, launch, source, start, and wellspring.
Okay, I couldn't hear everything, but basically you said it's the foundation or the start.
Yes.
You could also think of the beginning. Okay, so origin is the start or the beginning. Yes.
So where it comes from.
Where it comes from, the start. Cloney, what is origin in Afrikaans? Okay, right. So we spoke about frame of reference. You said if I want to know where Zara lives, then she must ask me, but ma'am, where are you starting from? Are you starting from the school? Are you starting from your house? Are you starting from Checkers? Where are you starting from? Okay, so frame of reference is your starting position. Okay, it's like when I say the attendees are a very yeah. They're a very lively class. Then my frame of reference is from the 3 English classes that I have, you are the most lively one. Okay? But you can defend, or I can speak to another teacher. Let's say I speak to Miss Siberocha next door. She says, no, the ADs are a very lively class. It is just because what is my frame of reference? What is my starting point? I have these classes, she has these classes. Okay, I can say, I think mathematics is very easy, and then you can say mathematics is difficult. It's just because mathematics come easily to me, but languages does not. But to you, languages comes easily, mathematics does not. So frame of reference is where do you start from? Here's Flonnie.
Afkoms.
Afkoms, ja. So in Afrikaans, sê weer?
En oorsaak.
Oorsaak. Oorsprong?
Ja,
Oorsprong.
yes, I was just leaving the others.
Nee, maar oor is definitief nie oorsaak nie. So dis oorsprong of wat het jy gesê is die antwoord? Afkoms. Okay, so where would we use the origins? Like, what is the origin of the Sotho language? Where does the Sotho language come from? Lesotho. That's the origin of the language. Okay, so this is the afkoms. Okay. Right, yes. Say again?
It can also mean two different meanings.
That's what I just said. All right. Okay. Then we also spoke on Friday. We spoke about distance and displacement. Okay. Now, first, before we can speak about that, we'll speak about rectilinear motion. Rectilinear motion, and we use mostly the word linear motion. Linear mean straight line. So it's motion in a straight line, either up or down, or left and right, or positive and negative, or wherever. Okay, then you must always indicate a positive direction. You must always say, let's choose right to be positive. Waar toe gaan jy, Gali? Gali, what's wrong with that green? So, do you think it's a good idea to throw it back? So, what do you think is the appropriate manner to handle this situation? Ma'am, the green is finished. Can I quickly replace it? Gali, rather than replace it, throw away the one that's not working.
That's fine. Yes, fine. Nice fine.
Think. Okay, are you going to waste a lot of time doing this, or are you going to be quick? All right, so you must always indicate a positive direction. So if you have something going up and down, then you're going to tell me in your answer, I choose up to be positive. If you have something going left and right, you're going to tell me, ma'am, I choose left to be positive. Okay, so you choose a positive direction and you show that to me. Okay, then what was distance? Now the symbol for distance can either be a D or an X. You'll see I use X a lot because that is a bit more, it's a newer symbol, but all the textbook and so forth will use the letter D. Distance is the actual path length that your feet walk, that we move when we change our direction. It's a scalar and it's measured in meters. And displacement is a triangle X. Now that triangle stands for the change in. It's delta, it stands for the change in. So displacement is the change in position of an object. Okay? It is a distance moved in a particular direction, and therefore a straight line path between the starting and the end point. Okay, so that which is written in italics or cursive is not part of the definition. The definition is that part there. This is just further explanation. So if I ask you what's the definition of displacement, you can tell me it's a change in position of an object. But in your own words, what is it? It is the straight line path, a direct line between your start and your end point. Okay, and it is a vector measured in meters. Right, then we're going to go to resultant vector. Resultant vector. Okay, now let's say you have a job where you get an income. Okay, and let's say your income for the month, is 1,000 rand. Okay, that's what you get. But you have a few expenses. Okay, let's say your expenses, you owe someone 200 rand that you borrowed. Then someone owed you money, so you also get 400 rand because you're a businessman or woman. let's say you want to buy new shoes. Okay, and you must also buy your own data of 200 rand. What is your net salary, your net money in your account? How much money do you have left?
500.
Thank you. 500. Okay. Now that which we have there, that is your net. Do you speak about saldo? Saldo. In accounting? No, at the end when you make those lines, what do you write?
Net salary.
It can't be net worth. You just write total. Rarig.
It's net profit.
All right. Okay. Now that net is actually abbreviation for netto. And another word is what is the word that has the same meaning? Yeah, but it's not a synonym. Sounds the same. Or is it a synonym? It is a synonym. A synonym for netto is resultant. So you can speak about net worth or your resultant worth. What is it that you're actually worth? Okay. So with that same thought in mind about adding and subtracting, let's say we have here pizza. Did any one of you that got a pizza at first break? Second break? Okay, no you didn't. Well, all right, there's a pizza and you love pizza and now you fight over it. Okay, so let's say Nyakalo grab hold of the box. She pulls here with a force of 15 newtons. And where are we? Bukamuso grabs hold of the box. Who's stronger? And he pulls with a force of 30 newtons. What will the resultant force on this box be? It will be 20 newtons to the right. Okay. So the same idea of net worth, where you add and subtract, same idea applies here. So you look at the forces, you see they're in opposite directions, so you're going to subtract them from one another. Since this one is bigger, the net or the resultant vector will be to the right. Okay. So here's a definition of a resultant vector. A resultant vector is the vector sum. What does the word sum mean again?
Plus.
Plus. The vector sum of two or more vectors. Then the definition doesn't stop there. Okay, it goes on. That is a single vector that has the same effect as two or more vectors added together. Two or more vectors together. Okay, so a resultant vector is the vector sum, or it's a single vector that has the same effect as all of them together. Okay. Alright, so collinear, linear means in a straight line. You can either, if they're in the same direction, you add them together. Opposite directions, you subtract them from one another, right? Okay. So let's say this is a force of 10 newtons and this is a force of, they look the same length, also 10 newtons. What will the resultant vector be? 20 newtons, but a vector is has magnitude, size and direction, so it will be 20 newtons to the right. Let's say this one is 30 newtons and this one is 50 newtons. Okay, Bukamusu, when you say negative 15, which direction did you choose to be positive? Yes, so what Bukamusu said is he said he chose to the left to be positive. So then you have 15 minus 30 gives you negative 15. That's not wrong. But we as scientists are never allowed to leave our answer in the negative. So you're going to say, all right, that means 15 newtons. And since I chose to the left to be positive, and since my answer is negative, in what direction must it be? To the right. If left is positive, then right must be negative. Since my answer is negative, that means it must be to the right. Same answer than the rest of you, right? You would have gotten 15 newtons to the right. Okay, let's look there. It says, 2 men pull on a rope. One exerts a force of 500 newtons due east, and the other a force of 700 newtons due east. Now, that's just a fancy word for saying east. Due east, same as saying east. What is the resultant force on the rope? So we have a force to the right of 500 and also to the right of 700. What will the resultant force be? 200. If both is to the right. 500 plus 700 gives you 1,200 newtons to the right. Okay, the next one says, a boy walks from the front to the back of a moving bus. If the boy walks 10 meters and the bus moves 70 meters, calculate the boy's displacement relative to the ground. Okay, so let's check. Here's my bus. Okay, this is a big bus. Here you stand, you wave to your friend, bye. Your friend gets on the bus and he walks 10 meters to the back of the bus. While that is happening, the bus is moving 70 meters to the right. What is the resultant displacement? Okay, so you all said, I choose to the right to be positive. Subconsciously, you all did that. And then you said, all right, the resultant will be 70 minus 10, and that gives me 60 meters to the right. Okay, not too difficult. Okay, your homework will be now number 1, 2, 3, and 5. Okay, but I need to help you a bit. It says there, a boy walks from the one corner to the opposite corner of a rugby field by first walking 100 meters north and then 50 meters west. Okay, so he walks 100 meters north and then 50 meters west. Okay, now they ask, determine the distance he walked. What are you going to say? He walked 100 meters and then 50 meters. 150 meters. Then I ask you, graphically. Now, graphically means you must draw it to scale. So you're going to take out your ruler and you're going to draw it. Your scale is 1 to 10. So if this line is 100 meters, how long will your line be? 10 centimeters. And this one is 50, then it will be 5. So you're going to draw with your ruler 10 centimeters, 5 centimeters in your book. Graphically determine his resultant displacement. What is displacement again? The direct line between start and finish. Calculate it graphically. So if you're going to use Pythagoras, you will get no marks. Okay, so you're going to take your ruler, you're going to draw a line from there to there, measure it off. Let's say your line that you got was 7 centimeters. What will his displacement be? 70 meters, because the ratio is 1 to 10. Okay, are you with me? Right, so that's what you're going to do there in your book. Same thing at question 2. At question 3, I say a ship sails north and then east. And then I say calculate his resultant displacement. Now you can use Pythagoras. Because I said calculate. Graphically, you must draw it to scale. Calculate, you can use calculations. Then 4 we've done. And then 5. They say there a motorbike produces a driving force of 500 newtons. So that is his engine. 500 newtons. As they move westwards, so west is to the left. When the rider applies the brakes will cause him to slow down. Yes? A frictional force of 150 Newton acts on the wheel. So friction causes him to go slower. So there's 150. Calculate the resultant force on the motorbike. Are you with me? What to do there? So that's 500, that's 150. What is the resultant? Not too difficult. Sharp. Alright, so you can start with that. You have 10 minutes. You can actually finish